So dilation, making things bigger or smaller. So it's a transformation that may change the size of a figure. I do not want to highlight that in black. It's a bad color for highlighting. Let's try again. Dilation, a transformation that may change the size of a figure. It requires a center point and a scale factor. Scale factor, that should sound familiar to us. What did the scale factor do when we talked about similar triangles? Scale factor, it wasn't that long ago. Yeah, it's bigger or smaller, same thing as a dilation. So if we had a scale factor of 1 to 2, we knew that if this first triangle had all the sides of 1, the second triangle would have all the sides of 2. That's really the same thing that the dilation is going to do. Just a few things we need to know. Dilation, we're going to focus on what the absolute value of it is. We can have negative dilations as well. Negative dilations just means it's going to go kind of backwards instead of forwards. So we're going to focus on the absolute values. So if we've got the absolute value of r is greater than 1, it's an enlargement. So like if we have an r value of 2 or a scale factor of 2, that means that our diagram is going to get bigger. The new image is going to be bigger. Okay. If we are in between 0 and 1, it's a reduction. 0 is a little bit redundant there because we have the absolute value signs, but that's okay. Reductions means we're going to start off big and we're going to get smaller. And then if we're equal to 1, it's called a congruence transformation. So that means we have the same exact diagram. Everything is the same about it. It's just in a different location or right on top of itself. Okay. And then the way how we find the measurement, if it's about the origin, this works. If it's not about the origin, it won't quite work like this. But if we have p of xy, so this is our pre-image, and it's centered at the origin, our scalar factors are, we just multiply our x and our y value by that r to get our new point. So for example, if I tell you, if I have a point 1, 4, my r value is, I don't know, negative 16. Okay. My new value, my p prime, my new point where that would be, would be 1 times negative 16 is negative 16, and 4 times negative 16. Higher than that. I should say lower, but negative 64. So that would be the new point. So whatever value that r is, we just have to multiply by both of those values, and then we get the new image.
Wait, what does the r stand for, though?
It's our scale factor, or it tells us if we are enlarging or reducing. Yeah, it's not s, it's r.
It has to be us.
Has to be r. Well, r is what you're going to see it being, so that's just a standard practice.
It has to be r.
All right, so let's look and see if we can do this. So here I have triangle ABC. A is at 2, 3, B is at 1, negative 2, and C is at negative 1, 2. We want to find the image of the triangle ABC after a dilation centered at the origin with a scale factor of 2. Sketch the pre-image and the image. So what do you think we should do first with those 3 points? Plot the 3 points. All right, so we got 2, 3. There's A. 1, negative 2, that's B. And negative 1, 2 is C. Now we are about the origin. So that means, since we're about the origin, what can we do with the 3 points? Times them each by our r value. What's our r value here? 2. So if we times them each by 2, A prime ends up being at what point? 4, 6. B prime ends up being at 2, negative 4. And C prime ends up being at Yep, negative 2, 4. And now you just plot those 3 new points. So A is at 4, 6. So there's my new A value. So there's my A prime.
What do you mean it's about the origin?
That means that it's being dilated using the origin. It'll sometimes use other points, and we'll talk about that next. So our new B is at 2, negative 4. And our new C is at negative 2, 4.
So it just gets bigger around it.
Yep, so that got bigger. And it got bigger centered around the origin. Now I do want to show you another way how you could have gotten those points. Okay. And the other way is just by counting on your graph. So if we want to increase it by 2, if to get to A, I have to go 3 up and 2 over, the new A should be 6 up and 4 over. I just times them both by 2. Okay. The original C was 1 to the left and 2 up. So the new C should be 2 to the left and 4 up. The original B was 1 over and 2 down. So the new B should be 2 over and 4 down. Does that make sense? I mean, it essentially is doing this. You would just be doing it on your graph right away without writing this step out of writing your points down. Make sense? That's going to be the method we're going to have to use when we're not centered at the origin, which will be our next example. So,
When you're not centered at the origin, you gotta count like that.
yep. So here we have triangle ABC as vertices A is at 2, 2, B is at 1, negative 2, and C is at negative 1, 1. We want to find the image of triangle ABC after a dilation centered at 1, 1 with a scale factor of 3. So we'll start off by plotting our 3 points.
You'll be pretty good at graphs by then.
2, 2. You should be pretty good at graphs already. B is at 1, negative 2, and C is at negative 1, 1. Okay, now we're centered at 1, 1. We are not centered at 0, 0. So we also want to indicate that somewhere on here. So I'm going to put my new center at 1, 1. And so now whenever I'm referencing things, I'm referencing from the point 1, 1. Okay, so we want a scale factor of 3. So here, if originally I go up 1 over 1 to get to my A, what will I have to do to get to my new A? Up 3 and over 3. So there's my new A. To get to B, what did I have to do going from my point 1, 1? Down 3. So down 9, we'd have to times it by 3. 1, 2, 3, 4, 5, 6, 7, 8. Your graphs, I believe, have that point on there. Yeah. You should just make it. Okay, and then C, what did we have to do? 2 to the left. So instead of 2 to the left, I'm going to go 6. So 1, 2, 3, 4, 5, 6. There's my new C. And then connect those for your new image.
Wait, so we can't multiply it by?
No, we can't multiply it by it because it's no longer centered about the origin. It's centered about that point 1, 1.
But I'm really lost in how you're getting like 3, 3. Like I'm so lost.
You times.
Oh, okay. You just, it has a scale factor of 3 here. So from our point, to get to A, we went up 1 over 1. So since our scale factor is 3, we have to times those each by 3. So instead of going up 1 over 1, we're going to go up 3 to the right 3. Okay, so for each of those, however we moved, we just had to times by 3. Does that one okay? Okay, and then the other types of problems I'm going to give you is I'm going to give you 2 images, and then we have to figure out what we have. If we have a reduction, if we have a dilation, or if we have a congruence transfer. Oh, wrong side. There we go. So we want to determine the scale factor used for each dilation with the center C. Determine whether the dilation is an enlargement, reduction, or congruent transformation.
enlargement, consider congruence.
Yeah, there's two ways that we can do this. We can certainly count. We can also just compare the lengths of the sides. So like here,
Which
if
one's
we-
the start?
the starting one's the one in bold. Nope, the starting one is the dashed one, and the one in bold is the new one. So here, this one would be, if we go from the dashed to the bold, it becomes bigger. So this would be an enlargement. Yep, we'll get to that one in a second. So now to determine what the scale factor is, we have to figure out what it had to be multiplied by. So you could do this two ways. The first way is you can count it. So you can say, okay, so originally from here to this point right here, I went up 1, and here I'm going up 3. So to multiply by 3. The other way is you can look at the length of one of the sides that you know. That's the way I like doing it. So here in this bigger triangle, I know 1, 2, 3, 4, 5, 6 is the length of that top side. 6 over 2 is the length of that one, and 6 over 2 reduces down to 3. So here my enlargement factor, my scale factor was 3. Okay. If we started at the big one and moved to the small one, it would just be flipped and be 1/3. All right, so here for the second one, enlargement reduction or congruence transformation. Yeah, this is a congruence transformation. They are completely identical to one another. They're just in a different spot. So a congruence transformation, we know the R value is equal to 1. The absolute value of R is equal to 1. But now, how do you think we got it to move down here? How do you think we got it to move in a different spot? So if we view this as your origin, this would be to the left 2, up 1. Right? And over here, it's to the right 2, down 1. So what did that have to be multiplied by? -1. So here your R value is -1. You have the R, that flips it or kind of helps it rotate about the origin. Is that okay?